Hello everyone, this is Miss James, and this is a brief video that shows you how to solve one parallel circuit R-total problem. So let's first refresh our memory about what a parallel connection means. So a parallel connection is when there is more than one path for current to move around the circuit. So charge could come out, when it comes out of the battery, it has a choice. It could go through lamp A or it could go through lamp B. Now the left side is more of a realistic looking diagram. The right side is a circuit diagram, but they're both really trying to represent the same thing. Let's try the problem. Oh, first let's figure out what our problem solving steps are. Remember, these are the steps you use to solve each problem. First, two steps involve setting up the problem, and really almost any problem I can give you, you should be able to do the first two steps. You just need to draw a diagram of what's happening and make a table of what you know and what you need to know. Then you're going to choose an equation that best fits your situation, plug in the numbers that you've already organized in the table into that equation, and solve. Alright, so here let's look at our first problem. We have the three resistors connected in parallel. The first two are 30 ohms and the last one is 60 ohms. What is the total resistance? Alright, so what's step one? Oh yeah, draw a diagram. So let's draw a diagram. Here's the diagram. Notice that it's got the three resistors in parallel, so there's multiple charge paths. Current can go through R1 and back to the battery, or it could go through R2 and go back to the battery, or finally it could go through R3. Notice that I've put in the numbers in the diagram, so I know looking at the diagram by itself that R1 is 30, R2 is 30, and R3 is 60. And finally, I make sure that I'm put down what I'm looking for. Because you don't want to answer the question that you want to answer. You want to answer the question I want you to answer. And this keeps it in the forefront of your mind. So now the second step is make a table. And that's what we're going to do next. We've got all the resistance values. We know it's a parallel connection. And we're looking to find our total. So let's organize that in a table. Here you can see below on the left side of the table I've got all the things that I've given, and on the right side of the table I got what I'm looking for. So what's the next step? Oh yeah, we've got to choose an equation. Now when you choose an equation for these problems, there are two possibilities. One is that you get the total resistance by just adding them up, but that happens in a series circuit. That's actually not going to be useful here. For a parallel circuit, we can't just add them up, which is kind of a bummer, but there you go. We need to add up the inverses, because the more current paths that we have, the less the overall current, because there's more choices for the charge to flow. So we can write the equation as 1 over R total equals 1 over R1 plus 1 over R2 plus 1 over R3. What's next? Oh, next on the list we got to plug in those numbers. So look at the table, look at the equation, and here you go. We've got our equation and now we've plugged in the numbers. Now what's the last part of the problem? Is solving. Now this equation is a little more complicated to solve than the series equation, so let's go through it fairly carefully. Okay, first of all, you could just literally plug it into your calculator. So go 30 and hit the x to the minus 1 button, add 30 x to the minus 1 button, add 60 x to the minus 1 button, and the calculator will do all the math for you. Of course, 30 and 60 make the math kind of easy to find the common denominator. So 60 is the common denominator. And here's what I'm going to do. 30 goes into 60 twice. 2 times 1 is 2. And I've got another 2 from the second 30. And finally, I've got 1 over 60. So 2 plus 2 plus 1 is 5. And so 1 over our total is 5 over 60. But I'm not interested in 1 over our total. I want our total. So our total equals the inverse of 5 over 60, or 60 over 5, which is 12. And indeed, the correct answer is 12. As I said, you can go through and do the whole common denominator thing, but sometimes that just won't work because you won't be able to find a common denominator. Make sure you can get the correct answer plugging into your calculator. And if you're struggling, feel free to come in for extra help. Have a good rest of the lesson. Bye.